Thanks for viewing our poster. I'll present data from a screening task that we administered as part of a large neuropsychological test battery investigating the underpinnings of developmental prosopagnosia across the lifespan. Developmental prosopagnosia, or DP as I'll call it, is characterized by difficulty recognizing faces despite normal vision and IQ. The extent to which DP is a face selective impairment remains an open question. It's known that some DPs can achieve normal accuracy scores on face processing tasks that have lengthy presentation times, for example, the Benton face recognition test, but DPs take longer to respond than neurotypical controls. Therefore, longer response times may be used as an indicator of face processing deficit in DP. The matrix item reasoning bank is a fluid reasoning task that we used in order to screen for any wider cognitive deficits that might explain poor face test performance. It's similar to Raven's matrices but is computerized. Participants are shown a series of 3x3 grids and must select one of 4 possible abstract shape solutions that will correctly complete the grid. Participants have up to 30 seconds to complete each trial, and task instructions stress neither speed nor accuracy. The test ends either after all 80 trials have been completed or after 8 minutes, whichever comes first. The task design therefore means that participants may complete a different overall number of items. So to results, here you see a density plot showing the distribution of accuracy scores. Accuracy is calculated as the number of correct trials divided by the number of completed trials. Darker blue shows the DP group scores and the lighter blue controls. Welsh's independent sample t-tests indicated that DPs were significantly more accurate than controls, and Bayesian independent t-tests also provided moderate to strong support for the alternative hypothesis. However, when looking at the total number of correct trials completed within the 8 minutes allowed, shown here on the right, we see a clear shift in score distribution compared with accuracy. In terms of number of correct trials, the score distribution was almost identical in each group. The reason for the difference in accuracy scores becomes clear when inspecting response time. Here we use correct trials only. DP's item response time, shown in dark blue on the x-axis, was on average significantly longer than that of controls. In conclusion, DPs adopted a different strategy to controls on a visual processing task that did not involve face stimuli, taking longer per trial. We suggest, therefore, that a similar slow approach by DPs to face tasks should not automatically be interpreted as a deficit in face processing ability. It could indicate a strategic difference in approach or, alternatively, a more domain general deficit extending beyond faces. Longer response time among DPs might facilitate slower featural face processing, but may not be driven by it, as is often argued. Please do contact us with any questions or feedback. Thanks for your time.